So in this first example, we've got this function f of x equals 2x minus 1. So the first thing we want to do is sketch the graph of this function. So let's lay down the coordinate axes. The vertical axis is the y-axis. The horizontal axis is the x-axis. That's going to be our input values. And now let's put some tick marks on here to indicate scale. So for example, there's a value of 1, there's a value of minus 1, 1, minus 1, and so on. And hopefully you recognize that the function f of x is a linear function. It has a slope of 2 and it has a y-intercept of minus 1. And so we can now plot this on the coordinate axes quite easily. The first thing we do is locate the y-intercept. That occurs at minus 1, so the graph is going to go through that point there. And then we recognize that the graph has a slope of 2. So in other words, for every unit that I go over to the right, I go up 2 units. So for every unit I go over to the right, I go up 2 units. That means that the graph is going to go through that point there as well, where this value is 2. And so I can draw a line through these points, and it'll look something like that. That's the graph f of x equals 2x minus 1. Now we can find the domain and the range of this function. First, let's think about the domain. The domain is the set of all possible input values, and because this is a straight line, we can see that any value of x is a valid input value. So the domain is simply the set of all real numbers. We would write it like that, or another way to write it is maybe in interval notation where we'd write it something like that. The interval from minus infinity to infinity. We can also consider the range of this function. And again, because this is a straight line, we can see that as x varies over all the possible values in the domain, the value of y that's swept out is all possible real numbers as well. And so the range is also the set of real numbers, or we might again write that in this notation. Okay, let's consider this second example. Here's the function g of x equals x squared. And again, let's begin by sketching a graph. First, we lay down the y-axis and the x-axis. And again, let's put some tick marks on here to indicate scale. So there's a value of x equals 1 and 2, a value of x equals minus 1 and minus 2. And on the vertical axis, let's go all the way up to 4 in this case. Now we want to sketch a graph of the function. The first thing we can do is note that when x equals 0, g of x equals 0. And so the graph goes through the origin. Now we can just substitute in a few different values of x to get a sense of what the graph is going to look like. When x equals 1, the value of the function is 1. When x equals 2, the value of the function is 4. And in fact, this is a parabola, and so we can sketch out a rough curve that's going to look something like that. That's what it looks like for non-negative values of x, and we can do the same sort of thing for negative values of x. You can probably already see that this is going to result in a mirror image of this curve in the y-axis. When x equals minus 1, the function again equals 1. When x equals minus 2, the function again equals 4. And so those points also lie on the graph. And again, we can sketch a rough curve, and it's going to look something like that. That's the graph of the function g of x equals x squared. Now we can consider the domain and the range of this function. Again, let's first consider the domain. What are the possible input values for x? And you can see from the graph that any value of x, any real number, is an input value. So the domain of the function is r. Or in terms of our other notation, we might write that as the interval from minus infinity to infinity. What about the range? Well, we can see that the range of this function is not the whole set of real numbers because we never get an output value that's negative. And in fact, we can see from the graph that the output values are always 0 or positive. They're all non-negative real numbers. And so we can write this using set notation. First, we have curly brackets, and we say that the range is the set of all values y such that, so this vertical line means such that, y is greater than or equal to 0. So the way we read this is all values of y such that y is greater than or equal to 0. And again, in interval notation, we might write that as the interval from 0, including 0, so square brackets, up to positive infinity.